An ambulance moving at 20 meters per second emits a frequency of 800 hertz while moving towards a stationary observer. What is the frequency heard by the observer? Assume that the speed of sound is 343 meters per second. Well, first of all, let me point out that the sound is moving towards the observer. So that means that the observed frequency is going to end up being greater than 800 hertz. So how do we end up using this formula to obtain greater than 800 hertz? Well, the observed is greater than 800. The source is 800 hertz. And for us to end up getting an answer which is greater than 800, that means that the numerator must be larger. Numerator must be larger than the denominator. So I know that the observer is not moving, so this ends up being 0. So the way we end up using this equation, we're going to have to subtract the speed of the source. So let me just rewrite that. We have the source moving towards the observer. We know that this is equal to 0. So, and moving towards observer means that we're going to subtract the 20 meters per second. That is the speed of the source. So now we can rewrite the formula. Frequency of the observer is going to be equal to the speed of sound plus 0, because the observer is not moving, divided by the speed of sound minus the speed of the observer, times the frequency of the source. Sorry, I misspoke. This is the velocity of the source, this 20. So that'll be 343 divided by 343 minus 20 times 800. So 343 divided by 323 times 800, which means that the observed frequency ends up being 849 hertz, as we predicted.